Hey, welcome to the metal building show. I was thinking about kind of just chilling out when we get these things to go live. That way, like the notifications from YouTube or whatever go out. But I mean, we do these in the middle of the morning part of the work day. So usually don't get a lot of live viewers. Also, for everybody that is subscribed to the channel, like if you watch these and you're subscribed, you'll notice that we re-released all of the previous episodes that we've done. So you probably got blown up there. We realized that we were running into some pretty significant audio problems and we wanted to fix that for you guys. So that's why all those were updated. But my name is Eric Beavers and I am the owner of Great Western Building Systems, and these guys help me out. Go ahead.
This is Jared Miller. I'm Chief Detailer here at Great Western Buildings.
Aaron Cowdy. I am the yard manager here at Great Western Buildings.
And I'm Justin Larwick, the media geek for the company.
Justin, how are you doing getting ready for the Argonia trip?
I'm doing great.
Are you?
Yeah. I got a freshly painted, beautiful rocket ready to go. I got a packed bag sitting on my couch at home. I'm ready to go. Let's do it.
Right on. Trying to pull up the live stream chat. Is that the chat or is that? Yeah. I think that's what that is. I don't know. We'll see if we get a comment or something. Yeah, Garrett's all out there stressing out. He's trying to get out first thing.
And yeah, he's leaving a bit early.
I can't leave until tonight. He just doesn't want to drive through the night. I'm like, well, hey man, sorry.
Yeah.
But okay. Today's topic, we're going to do nomenclature. We're going to talk about, just words and things that everybody might not be familiar with. Yeah, we cover a lot of this stuff in the other videos and things, but never in detail. And considering that we got Aaron here, I'm hoping that you're going to talk a lot about tools. You know, not everybody knows what a nibbler is or an electric shear. Hi, Melinda. Thank you for writing the chat there. Jared, you're going to go over a little bit more of the engineering type stuff, and I got some building parts, so we'll get rolling here. If anybody has any questions on something specifically that they've been wondering about, a process, the way a part's manufactured, what the difference between G30 galvanization and G90 galvanization, and the difference of pre-galv versus hot dip galv or something. I'm just spitballing. If you guys have a question, something that you want to know more about, tell us. So who goes first?
I can start. All right. I think the first thing I wrote down was a beam clamp. That's a pretty important part for setting rafters and columns. Along with that beam clamp, the other part that you would want is a sling and also a clevis.
What is a clevis?
Well, there's a beam clamp that's going to hook onto the columns on the top or rafter.
So we jumped right into it. We jumped into the obscure stuff first.
Right.
All right.
I'm trying to find a picture of one being used.
That would be nice.
Oh, there we go. Kind of like this.
There we go.
Yeah.
There we go.
That looks European.
It does, doesn't it?
Yeah. This picture right here, I once talked to an engineer or somebody, and what were we doing? Jared, I think you're a part of it. They use this picture saying, hey, a beam clamp can't be used to lift a beam. Those are to hang something from a beam. And I was like, no.
Oh, why is that beam? I like the picture on that. I like the picture on that, how the beam's upside down. That's pretty cool. I'd like to see how that works.
Well, no, but you can also use them to clamp on. Then you could put like a hoist.
That's true. Yeah.
You put a hoist or something under there. Okay. A beam clamp, that's a good one. I wouldn't have thought of that.
Yeah, I wouldn't have thought of that either.
Right. While we're on that topic, I think for most people on smaller jobs, lifting eyes. Mm-hmm. Yeah. So I like them for raising columns, right? And you can get them in 1/2 inch. They're kind of expensive, but they're super strong, high grade steel. and you can bolt them into. I mean, heck, we've lifted rafters before them off of Purlin clips on the anti-roll gusset clips to make to make kind of a spreader deal there.
I've actually never used those, so that's interesting.
Beam clamps way better. They're kind of expensive, and not everybody has one.
That's true. Let's go. You want to just keep going down this list here?
What was the other thing you said? A strap of some sort?
Yeah, a sling. There's all types of them. Yeah.
Right. Basically a toe strap or something, but they make them specifically for lifting.
Yep. Yeah, like that U-line one. It's pretty good, 2-inch.
I've never heard
smaller
of
jobs.
Lifting sling. That's
your clevis to put onto your beam clamp. But some beam clamps come, you don't necessarily have to have that. It's a good thing to have, just depending on what you're lifting and how you need to lift it. So,
and I am on Grainger's website here. I mean, I'm just picking the best image. Unless you have an account with Grainger, don't go to Grainger. This is like extra retail pricing, right? Like, so, this little 7/8 inch clevis, doesn't cost $13. Normally, but from Grainger, sure.
Yeah.
All right.
Bullpen, also a spud wrench. A bullpen is different than a spud wrench. As you can see, a spud wrench.
Bullpen? Do you mean like a drift pin?
Yeah, bullpen to be able to. I usually use it when it comes to putting connections together. Yeah, not really that.
So the bullpen you can bang on.
You can bang on it. Yeah,
I always call them drift pins. So what do we use a drift pin for, or a bullpen?
A bullpen usually for connections when you can't get everything lined up, and it's just a pain. You can get holes lined up really easily if you put that in there and just swing on it and hit it, and then you can get all your bolts into the holes, and then you just go to the other side and pop it out.
Right.
It's actually really nice.
So I've seen these used mostly on big, heavy, large buildings. Is when you see them more.
Yeah. A huge haunch connection.
Yeah.
It's just really hard to get your spud and try to go from each side. With this, you can just definitely helps.
Yeah, like a 30 by 40 or something. You probably you're not going to need this. Your hands are strong enough, right?
Yep.
If you do need that, get off the lift, go down to the bottom, measure those bolts again.
Yeah. Yeah. If you need that on a 30 by 40, you should probably. And then, your typical spud wrench. They have fixed ones, but I always use a crescent. That helps for when you're doing connections of girts and purlins. And I always carry 2 of them. And use one to get the back of the bolt, and then you can get the front of the nut with your 3/4 or 7/8 socket drive to put it together. Those come in handy a lot.
I like them, and like you, I like the adjustable ones because it's like an extra tool. It's like an extra wrench in your bag.
Exactly.
Anything that's up there.
Ooh, that's the Klein too. Look at the price on the Klein.
I've started to really like Klein tools.
Klein they're great tools. They're American made, but they definitely have a price range on that, but they last for ever. Yeah,
it seems like their tools are like what Craftsman used to be before they changed it all over to China.
Right.
Let's see. I used to have a whole bunch left over from my dad and my grandpa. Really nice Craftsman sets from the 70s and 80s, but
yeah,
we won't discuss what happened to those. All right. I did want to do this though.
There you go.
As we were looking at prices. Let's look at Home Depot. This one looks really small.
Yeah, but these are, stuff like this. Yeah, stuff like this is good for our DIY where they don't want to have to go spend $40, $50, $80
on a one-time use. They're gonna, And actually, what I would buy 2 of these things.
Well, yeah, most definitely.
Yeah,
you definitely want 2.
You know what? I was thinking about a long time ago while we're on the subject of tools.
Yeah.
I was considering having like these big Pelican cases, right? That we could ship out to the job site with like inside of the warehouse box or something, like a set of tools that would be like a small rental fee, right?
Yeah.
Like it's not like a way to make money, but it's a way to cover the cost of the tools over their usage. And then, if the customer gets it, then, they would mail it back to us. We'd probably have to take a deposit or something like that. But where we could have a bunch of the specialty tools, like I was thinking, it'd be cool to have a mag drill in there just in case, like it could be like an SOB box, like only open in case of emergency. Right.
Yeah. That would be actually pretty cool for, DIY people that don't want to have to go. I mean,
Especially with the
going out buying tools. So if I got a building, I'd be like, yeah, I could use that as an excuse to get a mag drill.
Right. So a lot of our customers, that are putting these things up, they do kind of joke around, or I've talked to a lot of guys where they're like, hey, this is a good idea to buy that, or a good excuse. I think I could get this one wife approved.
Yeah, exactly.
Yeah. Talking to this guy, Keith, up in Montana, really, really cool guy. He's got a crazy building. Jared, you detailed it's the one with all the windows and stuff that we're making changes on.
Yeah. Right.
And he's like, I have a feeling that Keith has an awful lot of money, not only by where it's going and what the building is, but just kind of the way he talks. He's like, all right, now what tools do I need? Cause I'm doing this myself, I think he just recently retired or something. And I'm like, listen off. And he's like, well, what brand's the best? Like for that tool, I prefer DeWalt, but Milwaukee in this case is going to make the best one. And he's looking around. He's like, ooh, I got this Japanese one here, a purple Makita. And I'm like, ooh, that's nice. That's expensive. Right. But it will last forever. But yeah, it is a good excuse to buy some fun tools. But you don't have to spend all the money on it.
Nope, you don't. But that is kind of a cool idea, what you said.
Yeah, tool rental's a great idea. I think that's fun. I mean, it's not for everybody.
It's a real pain to put together and keep track of. Like, can you imagine the logistics? Like, okay, where is box number 32?
Yeah.
We ship 30 buildings a month like 50 buildings a month, and if that means, customer wants it, and then if they're keeping the box for 3 months or something like that, I'd have to have so many, I mean, we'd be talking about, tens of thousands of dollars. Plus,
we have talked.
Those aren't cheap.
No, and we have talked about that. Sending out, certain tools, like just in case, step bit or something like that.
A 7-inch angle grinder with a 1/4-inch cutoff wheel and a mag drill and an oxyacetylene torch.
Yeah,
only open in case of emergency.
Small bottles.
Right. Right. All right. What else you got?
Hammer drill, or and what it's usually called is a rotary hammer drill, and that's definitely going to be helpful. I don't know. They're let's see what the price range is on those, but
I'm gonna show you right now.
Yeah, well, those are Bosch.
I wrote Bosch because that's what I always think. But no, they have the
they have Makita
Bulldog
ones. Yeah. But yeah, those are going to be good for one, setting maybe overhead doors or walk doors. And then, those are going to be 3/4 to 5/8 bits. And then, for your base angle or base channel, a 1/4-inch bit to set hit pins.
I think this is the smaller, cheaper one here is perfect for base angle and base channel. This is inadequate if you're going to be drilling and epoxying more than 1 3/4-inch bolt. So in that case, you're wanting something with a bit more oomph.
Yeah.
But, ooh.
Oh gosh. What is that? What is that? $94 one? Oh, it's a Bauer. Okay.
Right. Yeah.
I was like, Hilti sells a $100 one? No way.
Right. It'd be like that's the replacement electrical cord.
Oh.
No. Okay. Don't
Wow.
Wow.
Don't buy one of these.
There you go. Should we get two? Just
Right.
because?
Let's get two.
We'll
Yeah.
put those in the rental box.
That's right.
Yeah.
But actually, speaking of renting, if you need something like this, go to the Home Center, Lowe's, Home Depot, or even the the actual rental store, like where you rent like a forklift or whatever from, and rent these. I would
Most definitely.
Yeah, unless you have a really good excuse and you're going to use, you're going to get $1,000 worth of use out of a.
Unless you put up one and you're like, well, I'm going to start putting these up.
Yeah. Having your own tools is clutch then.
All right, that's the rotary hammer. Good one, man.
Yeah. Snips, aviation snips, red, greens, and yellow, which is left, straight, and rights. And you can get them pretty inexpensive. I would suggest getting the nicer one, not super expensive, like $30. I know Klein makes one for about $50 a piece. Those Midwest snips are perfect right there.
Why do you call them aviation snips?
Yeah, I was going to ask the same question.
Hey, that's a good question. I don't know, but you see DeWalt calls it an aviation snip.
Yeah, that's weird. I've never heard that before. I mean, I
hadn't either.
I've always called them manual shears or snips, or left, right snips. Green, yellow, red. I
mean, that would be a Google question, I think. But
okay, I'm going to go fill up my coffee.
Hey, I got an answer for the aviation thing.
Oh, hold on. Aaron, you guys do save that aviation thing till I come back because I'm interested. But Aaron, I bet it has something to do with World War II. But Aaron,
I think so too.
If you can explain the left, right hand, and straight cut and their and where to use them.
Yep, gotcha. Yeah, so the left and right are essentially the direction that you're going to be cutting, where one side is going to lift up to make the cut easier as you go along. So if you cut on the right, the left side's going to lift up, and then you use the left one for the right side to lift up so you can make those nice straight cuts for stuff like gutter, sculptured eave, base trim, actually pretty much every piece of trim. I don't use the straight snips very much at all. I guess those are kind of good for, I guess I've used them on gutter to open up a hole, but really I just use the reds and the greens. And we have, I have a video on that, on the doghouse thing that we did that shows how that actually works, the application of using left and rights. And this isn't a bad set either. For $55 you can get all three. And Milwaukee makes pretty good tools.
You like the Milwaukee ones?
No, yeah, they're good for the customer. If I got Klein, I usually try to get Klein or DeWalt. That's actually the Midwest ones work really well. I have a set of those. They're not.
I'm not a hater. I use cheap tools, man.
That's okay.
So much hard. I've got Harbor Freight. I've got Milwaukee. It's what I've got.
Well, that's fine. Those Milwaukee snips would be just fine. $55, you get all three. They work just fine.
That's a deal, and you can always use them. But I have another idea. While we're talking about high end stuff.
Yep.
Blue Line doesn't make any.
Look up. Oh
yeah, Snap-on store.
Yeah.
Or Blue Point. That's what I meant to be searching. Blue Point. That's like the super high end stuff. Thank you, Bryce.
They have some really cool snips that see them, but
okay,
they have some interest.
Why aviation?
Some interesting snips. Yeah, why aviation?
So Eric, you're right. It's World War II. So I guess the aviation industry needed to be able to make really precise cuts. So that's when they were invented and put into use. Just specifically for aluminum and sheet metal. So yeah, it was World War II aviation industry. That's where they came from. Yeah.
Okay. Hey, we actually I want to answer Garcia's question here. Yeah.
Danielle.
Garcia's asks, turnkey metal building erector, equipment and crews. not sure how to define equipment and crews. But I think he's saying equipment and crews as part of a turnkey process. So, I guess I'll answer that.
Yeah.
Yeah.
So I think turnkey, there's two ways to look at turnkey, right? I think true turnkey would be going out, getting a GC and basically explaining what you want. And that's it. You're done, right? GC does the site plan. He buys the metal building or whatever. He procures the material. He pulls the permits, or she. There's actually a girl GC that we're working with right now over at here in town. Really, really smart lady. So I say he, colloquial he, 100% turnkey, right? As the customer or the buyer, you don't do anything, right? Other than at the end you walk in. Now, I think what Garcia's talking about is a turnkey erector. And Garcia, you can jump in here in the comments if I'm stating something different. But to me, a turnkey erector is going to be an erector that is going to either be able to handle the building purchase, basically like a GC, but not as the GC. He's going to supply the building, customers going out and getting their own permits, everything like that. Maybe their own concrete, maybe the building erector as part of the turnkey process is going to handle all of that. And then that erector is going to coordinate, basically act as the job site project manager, make sure that all materials, insulation is coming in at the right times. Equipment is arriving at the right times. They've arranged the crew, any subcontractors for utilities. That to me would be a turnkey metal building erector. They have their own equipment, or they'll lease it or whatever. And they have their own in-house crew. They show up at you. Usually then you're buying the building from them. But not always. There's a lot of turnkey metal building erectors. I mean, Mountain State Construction here in Colorado, one of our best. They buy an awful lot of buildings from us, but they also put up an awful lot of Great Western buildings. But I would not call them turnkey. They're just erectors.
Yeah, I think my grandfather for years with Rocky Mountain Steel, he was definitely turnkey.
Right.
But
Sure.
he now they primarily just do GC work, kind of got out of that. It's a lot better that way, especially when it comes to metal buildings. And you have a GC that understands metal buildings. That's also nice.
Daniel, can you explain what the difference between a hot rolled and cold rolled buildings and why cold form is generally cheaper? So I think what he's talking about there is a 3-plate or a solid web I-beam building, like what, a true steel building, like a Great Western building, compared to like a bolted frame building, like those metal sales sells them. They're called like Icon now, impact steel buildings. Cheap. I mean, but they serve their purpose. I think in that other video that I did years ago, we talked about them.
Yeah, I think it's, to Daniel, I think to kind of help with this too, is that, I think that you're talking about more of like the rigid frame design. You can do the cold form, but you're limited to the span. So you're not going to be able to do a 100-foot wide building, out of cold form, out of rigid frames, unless you got frames every 4 feet, so it just wouldn't make financial sense at that point. Whereas with a hot rolled, you can span a lot further, not only spanning, in both directions, width and length. So that's kind of we use cold form sometimes like on the end walls and stuff, but the load of the area helps govern that and helps kind of dictate, what we're able to use and what we're not able to use.
I think, the thing about a cold form building like what we're seeing here, right? This is obviously a super cheap building. It's basically dirt and Purlin material that we use to span between our primary frames. And this stuff is it's a lot lighter. So therefore it's a lot cheaper, right? It's not nearly as strong. Like Jared was saying, you're not going to be able to get those spans. A lot of times if you do try to get a bigger span, you'll need a flat bottom cord. But I think the benefit of them is there's no manufacturing time. It's all pretty much an automated process. It's just like running Purlin. right? Machine just starts shooting it out. Be careful with those. A lot of them, you have to bolt together all of the C-frames and stuff. They're not welded. They're putting bolts through all those holes, which is fine. I mean, our building, you have to put in a ton of bolts, but it's janky, man. Right? I think it's just not the same thing as a solid web I-beam steel building. Hopefully that answers the question.
I think so.
But yeah, they are a lot less expensive. That's for sure. But for a reason, right? I mean, you are getting less. You are getting a I'm not going to say an inferior product. Yeah, I am going to say an inferior product. You're getting an inferior product, but it doesn't mean that it's not a good product. That's what I guess I'm trying to say.
Sometimes you don't need it to do as much.
Yeah, small span. Who cares, right?
Buy what you need.
I think. Yep. Okay. What's next?
Shears and Nibblers. Electric shears and electric nibblers come in handy a lot. I've never really used nibblers. I typically use just shears for long cuts, either cutting off the edge of a roof panel or wall panel, or the most prevalent one would be, garage doors, overhead door framing. Jeez.
That looks just like it looks like the Milwaukee, man.
Yeah, it looks just like it. Yeah, I don't think you need to spend $300 on shears if you're just doing it yourself. I mean, you could also just use a grinder, but
yeah,
that can kind of rust and not look the greatest later on down the line. So I would suggest shears or nibblers. Have you used nibblers a lot, Eric? I have.
I don't like nibblers. I have a set. I've used them. I prefer shears. Nibblers are good when you're making a cross cut on a rib panel.
Yeah. And then usually I just use a grinder on that and then clean up the edges and take all the burrs off.
Right. I think with using a cutoff wheel to make your cuts, which is fine. And I think, really for like a curve cut, it's really the only way to do it for like a header trim. Or the best way. But long cuts that are going to be exposed to moisture, like you said, rust could be a problem. And I think rust is more of a problem because as you run that cutoff wheel through the panel, you're cooking the panel and you're baking that paint off, right? So you're damaging the paint next to the cut. So shears, some sort of a cold cut is better than a hot cut, but plenty of times a 4.5-inch cutoff wheel is exactly what the doctor ordered.
Yep. I could keep going.
Let's go. Let's look at nibblers.
Yeah, I've just never used them. I know what they do. Yeah, they just.
I don't like them because it's a skill to use them correctly. They will run away on you. And just chew up a panel. Bad, wiggly cuts, lousy cuts. I mean, they'll make good cuts. They're fast, and efficient, but electric shears, absolutely electric shears.
Yep, all day
is better than those. All right, let's do one more tool and then we'll jump onto parts.
Okay, yeah. I mean, let's just do a step bit. That'd be a good one.
Hold on. Daniel recommented. He says, so it's like a back-to-back C channel creating an I-beam. He's talking about the bolt-to-frame buildings or those cold form buildings. Yeah, exactly. 2 C channels back-to-back makes kind of an I-beam. Yeah. And we use those in our buildings a lot of times for like, when we have to do sliding doors, and sometimes we'll see them on hangar door openings, but we weld those together. That is a single piece. It's I don't know why we use those rather than I-beam, regular old wide flange. But all right, what were you saying, Aaron? I'm sorry, I cut you off.
No, you're good. A step bit. Now this is sometimes I typically use these on. Well, we know what we use on Gertz or Purlin. Sometimes they just don't match together perfectly. And a step bit is nice to have to get your second bolt in there. Or sometimes they have to do all 4 bolts. That can kind of be a pain.
That can based on the clip.
Yep. But using these, there's very inexpensive ones. You can get a 3 set for. The only thing you have to watch out for is you got to go slow, or you'll burn up the step, and you can't really use it anymore after that. So
Yeah, good tools, but they're expensive. So slow down and use cutting oil or
exactly.
some sort of coolant to keep those things. Once they get hot, they're done.
Yeah. And you can see the burn mark on it, and you're like, oh yeah, I ain't going past the 3/4 step.
All right.
Okay. Took up 30 minutes with tools.
Nah, we took up 30 minutes goofing around looking at aircraft stuff. Yeah.
World War II.
Right.
World War II.
All right. Jared, do you want to go?
Yeah, I got a few. Let's see. A Gambrel.
You're sharing the screen. Nice.
Yeah. Gambrel.
Cool.
A ridge roof system that has 2 roof slopes and, basically a barn shape.
Nice.
So that's
exactly what you think of when you think of like an old New England barn.
Yeah.
So there's that one. Next up,
should be fun.
Trying to explain that over the phone, the shape of that is always pretty funny too. I think people struggle explaining the shape of it's got 2 angles on the roof, as opposed to like a monitor that has 2 angles on the roof.
Yeah.
And this is something that's worthwhile bringing up here is, at least here at Great Western, all of these dimensions, the slopes on both sides, or I guess the upper slope and the lower slope, those can be pitched differently.
Mm-hmm.
And their location of the connection where the slope changes can be changed. And we can do these in basically any span that we want. I think the real limiting factor rather than span when it comes to width is really just the height, right? Because that first gambrel is going to be, or the first pitch is going to be at least a 12 on 12, 45-degree angle or steeper.
Mm-hmm.
And so you can get really high really fast.
Steeper than 45.
Yeah, I think that we've done 16 on 12. I think is the steepest that I've seen for that first pitch. Mm-hmm.
Wow.
And that's not the limit. I mean, we could go. We could go. We could go just off vertical.
Mm-hmm. Yeah. So there's Gambrel.
There it is. There it is. It's glory.
Sweet.
Justin hinted at the next one with a monitor frame. So it's just a rigid frame which has a raised center region. And you can see, like with this one, both roof slopes are at a 5 on 12, but kind of like Eric was mentioning, we can change those roof pitches and go as wide as you want here too. There's some where we see like almost like a gambrel. It's like the first part's really steep, but then the upper portion is really shallow. So we've seen all sorts of those. You also may hear this referred to as a Western style frame. We at Great Western generally use monitor, but sometimes when you go outside, they call it a Western style frame.
We use Western more often here. I think even on the website, we call it a Western style.
Okay. So yeah, generally, well then back here in the engineering department, we call it a monitor, but
that's because you guys are boring.
Yeah.
Call it too many roofs to have to put on.
That's right.
Let's see. And monitor can be, monitor's similar to the gambrel there. Here, I'm going to share my screen.
We don't do as many gambrels as I thought we would. We do a lot of monitors, though.
Lot of monitors. So there's this one, which a lot of people I think would not care for it, but this works good for the customer. Bob,
I love that
Bob Schmidt, our very first customer, his building was a monitor. Here it is.
Mm-hmm.
Yep.
Yeah, that's more
and
traditional.
And those pitches can be different. right? The pitches there don't have to be the same. Like you can have a steeper pitch on the lower side and a shallower pitch, or vice versa on the upper one.
What's the purpose of that? Of doing them
Just
drastically different?
sometimes.
Aesthetics.
Yeah.
Aesthetics.
Just architectural feel. Yep.
Mm-hmm.
I guess if I
Or-
did it, I would want it to shed snow or whatever. One
Mhm.
steeper, one lower.
Preston's building that we've had pictures on the show before. He's a monitor, so really good looking one.
Do you think they look better with a steeper or a shallower slope?
I think it's just important to get the proportions right, in my
Mhm.
opinion. Yeah. All right, Jared.
So the next one that I got, share my screen again. A hip and a valley. So a hip roof is when a steel building roof system that is formed by sloping planes where the angles of two planes is greater than 180 degrees. And then a valley is kind of where, same thing, but it's less than, or another way to kind of, I guess, define it is a valley is concave, or a hip is more of like convex.
So why greater than what you call a hipped roof? Something different if it's not steep enough?
No, it's more of like if you were, like where the bend is, right? So if you were to look at it more of like a piece of sheet metal, right, and it's flat, like okay, that's normal. But if you were to bend it down, right, that would be greater. So now it kind of forms that. Yeah.
Okay, I got you. So that's 180
Yeah.
degrees. That okay, understood.
Right.
Right. Makes sense. Yeah.
But yeah, that's the difference between a hip and a valley. We do a few of those a year, here at Great Western. So
Well, we
they're
do
always fun.
valleys pretty often.
We
Hips
do.
and mansards and stuff, not much. Don't buy a hip. We don't want hips. If you want a hip building, call some. I'm just joking. We can do it, but it's
We've
detailing
done
and engineering doesn't
Yeah,
like it.
We've done it. It takes time. There's a lot more moving pieces to that.
What about multiple hips that we've done before? That church in Louisiana that we did, I think that was 8-sided. Cool, like an octagon. Yeah, basically just a bunch
That'd
of
be
extra.
interesting.
We're getting off into the weeds.
Well, we did the RV Super Center. That one definitely has hips. As a hip roof.
No,
Oh, here we go.
So we've done it.
RV
Certainly
Super
do.
Center doesn't have a hip roof.
Doesn't it?
I think it's a valley.
What am I thinking?
Maybe on the lean-to.
No,
I thought it
No.
did, but I could be wrong.
I think you're right.
I'm scrolling through the videos trying to find it so I can look at it. But I remember it. I thought it did.
Oh, I don't think his video's on our website.
I'm on the YouTube. I'm on the backside of the YouTube.
No, anyways, it doesn't have any hips. It has some parapets.
Did it have parapets?
I could be wrong. I'm wrong a lot.
Jared,
my wife.
this is
right.
good.
Yeah, I like this.
Yeah, so this is the last one that I kind of have here as far as defining terms and stuff is, the difference between really the three loads that we're referring to. First one would probably be the dead load, which is the weight of all permanent construction in a steel building, such as floor, roof, framing, covering members. The stuff that would never move. You're not going to move a rigid frame. It's going to stay there, right? It's kind of a good way to help define that. And then a collateral load, which is the loads caused by permanent materials other than the steel building itself, such as sprinklers, mechanical, electrical systems, partition ceilings. That's more of a collateral stuff that could move, but probably won't once it's there. And then live load, which is loads that are produced during the maintenance by workers, equipment, materials, that sort of stuff. So objects that move, right? You walking around on your roof is considered a live load. It's there temporarily, and then it's gone. But it still has to be supported. So hopefully that helps kind of as far as, defining some terms and stuff as well that you may hear us throw around quite a bit. But that's what we're going for.
Alyssa says, Happy Wednesday. Happy Wednesday, Alyssa.
Happy Wednesday, Elisa.
That might be Elisa.
It is. That's my sister.
Oh, okay. I didn't know that. All right. Happy Wednesday, Elisa. All right. Is it my turn?
It's your turn.
It's your turn.
All right. Jared, are you going to be able to keep up with me on searching? I think the internet would be best.
Maybe. Yeah.
I could do it.
Right.
Okay. So
I know, but my internet is slow.
I can do it.
Say the difference between primary frames and secondary frames. All right, so we talk about primary framing. I refer to it usually as heavy iron, right? But what we're talking about is the fabricated I-beam, basically. Right? Can you pull up a wireframe drawing, Jared? Or wait,
you want to just go back to that? You could probably go back to like the monitor frame. Would that work?
Yeah, that would work. But hold on, let me look here.
Wireframe.
Here, we'll pull up Nucor's website. We have pictures like this from us here. Let's go. I'm gonna take over on the camera for this. There we go. So that even looks like a Great Western building. Nucor paints gray like us. These guys are always copying our stuff. It's thanks, Nucor. We like it. Right.
That's right.
Primary frame would be the I-beams or the rigid frame columns, the heavy structural support, compared to what we call secondary framing, which would be the girts and the purlins. So that's what I got there. But while we're on to that, let's talk about wide flange. So I think most people think of a wide flange as just an I-beam. It's actually not. It is an I-beam, but it's a very specific I-beam, right? Where a standard American I-beam is what we actually now call an S-beam. And wide flange is a structural beam. This is what we use in our building systems when we're using mill beams. This is, what we call them. They're made at the mill. We don't weld them together. And I think the one term that I'd like, everybody to understand is the difference between a web and a flange. So Here we have a web. This is the flange. So for us, inside flange would be facing towards the inside of the building. Outside flange would be facing towards the outside of the building. Usually we're using these as end wall columns, hot rolled end wall columns. There's also, similar to wide flange, would be the U-channel.
This actually kind of answers Daniel's question earlier.
Yeah, a little bit.
Yeah.
We have hot roll U-channels, which is basically the same thing as a wide flange beam, or structurally for us. But we'll use these when we need to combine an end wall column into a door jamb, where a C-channel won't work.
Once again, due to those loading limitations, we have to go heavier to make that work and make it pass. Yep.
Right. And so a C-channel for us is 16, 14, and 12 gauge, 12 gauge being the heaviest. But that's what we're going to use for door jambs. This would be part of the secondary framing system. Before I start going down that, Jared, have you ever heard the term H-beam?
I have. Yeah. Mm-hmm.
A lot of people call 3-plate H-beam.
I've heard that too, but
it depends on which way you flip it, I guess.
I thought it was the same meaning.
I think it has to deal with, back in the old days when we had drawings and, they had the paper turned sideways. So it was really an I-beam, but then they just turned the paper. Now it's an H-beam. And I think that it's stuck. So
there's an H-beam. There's an I-beam.
Yep, exactly. It depends on which way you flip it.
I wonder if that's true or not. I always thought that H-beam was defined whether or not the beam was 3 plates welded together. Like a taper frame would be an H-beam. That's what I always thought they meant.
No, I think it probably has to do more with when they're laying stuff out. Generally, they're laying it, on its side, creating more of the H shape. rather than standing it up because it would tip over, making it an I. So
I just looked it up. It looks like there's a difference in the distribution between the materials and the structures. So like the middle is the same width or the same length as the outside parts. If that makes any sense. So it's just it's a different distribution of materials for strength.
Okay. Well, that
That's
brings me
essentially-
to the next topic. Jared, can you pull up a frame drawing? We'll talk about built up 3-plate. Primarily what we're using in our building system for columns and rafters.
So just like a cross section?
Yeah.
I guess another name for H-beam is W or wide flange.
Wide flange. Okay. So Jared was right.
Mm-hmm.
Depends on which side of the table you're looking at in the meeting with. No, Steve, the H beam.
It's an H,
That's
not
right.
the I.
Not
That's it.
we're talking
That's
about,
right.
for you, it's the I beam.
That's right.
Right.
That's
Okay.
it.
Okay. So 3-plate, what we're talking about here is the web of the I beam, right? And then the inside flange and the outside flange. So I call them 3-plate. Other people call them built up. Built up just means that they're built rather than extruded in the hot rolling mill process. So this is what is on almost all of our buildings. And the easiest way to think about them is just as an I-beam or as a tapered I-beam. Inside flange, outside flange. Here we use a submerged arc welding process to actually put them together, but we're not going to get into manufacturing. So that is when we say built up 3-plate, sometimes H-beam, I guess. All right.
If you lay it down, it's an built up H beam.
Right. Let's do a fun one here. PBR.
Yeah.
Yeah. Let's pull up a PBR panel. Go to the website.
Making me thirsty.
I'm going to share my screen. We have panel. Here we go.
It's a really good one to talk about. This comes up.
Okay. PBR, right? So there's, when we say PBR, we're really just talking about an R profile. R as in the letter R, not hour, right? So this is a product that's been in the metal building industry long before Great Western. You know, we're talking 50, 60 years, I bet, maybe less. But when we say, so this is the R profiles, and what that means is major ribs on 12-inch centers with intermediate ribs on 4-inch centers between. So pan section, high rib, and then the PB. So you can buy just an R panel without the PB in front. PB is the Purlin Bearing leg. So it's a Purlin Bearing R-panel. Hopefully that makes sense. The reason this leg is here is that when you're lapping your next panel, this part over here, up here, this leg bears on the Purlin, or you can put it on wood or whatever. Anyways, it's a bearing leg, and it stops this part here. Like if you imagine it reversed, it was just an R panel. This is going to bend down under the force of the screw. You're not necessarily going to get the screw into both panels. This leg makes sure that you get that you screw into it for your laps. Make sense?
Yep.
Are you guys sure? Are you guys sure I can explain it to you again, just in case?
You might need to.
Right. Okay. And then the last ones that I'm going to hit on here, we were going to talk about jack beams and stuff like that, but let's, Jared, maybe you can talk about pinned and moment connections, or I can, but real quick, I do want to show everybody the difference between a Z and a C. Thank you, AI. Let's see an image.
AI's got you.
AI is on top of it.
Hey, look
There
at
we
that.
go. So a Z and a C are basically the same thing. It's just which way the flanges are pointing. And we use these as girts and purlins, headers, door jams.
And
But that's the only difference, right? And
I guess.
yep. And C's and Z's have the same kind of parts as an I-beam or as a channel. They have a web and they have 2 flanges, right? If you only had one flange, it'd be an angle. That's all I got. Jared,
Nice.
do you want to do moment connection or pinned?
I think I can kind of explain them both. So a pinned connection, are you thinking more about the, like in the frame or just like at the foundation, Eric?
No, like the actual connection. So a pin connection, or I'll do a moment connection, right? Or what a moment is. Moment is a twisting or rotating force, right? So sometimes you'll have people call rigid frames moment frames. I think that's technically true because they are resisting horizontal or lateral loads. Portal frames we call moment frames pretty often. But the connection itself is a moment connection, like to an anchor bolt setting. And we use pin connections, but anchor bolt connection is going to resist the column twisting, right? A pin connection is going to only resist vertical forces. And there's a change in the way that the base plate and that connection is done. So a moment connection, you're going to have bolts on the outside of the beam to resist the twisting and bending. In a pin connection, they're all going to be on the inside of the beam because they're not necessary on the outside. And actually, that's a good point onto why we have tapered frames.
Yeah.
Right. The bottom of a frame or a column, right? Because it is a pin connection and not a moment connection, they don't have to be as strong down there. And that's why we taper them down, sometimes even reducing flange and web thickness, just to save weight, which saves money, makes the buildings cheaper. So it's not necessary. So a lot of people want a vertical column. They think that's going to be stronger or better in some manner, but really it's not. Just costs more money. I had something else on that. Oh, well, whatever. Anyways, Daniel or Jay asks, how do hat channels work in a steel building system?
Generally, hat channels are, they could be, generally they're probably mounted to like our girts, generally like screwed to the girts. And then most common way that they kind of run perpendicular, to the girts, basically running the same direction as your eave height. And the reason that you would do that is that, like, if you were going to change the direction of your sheeting, you don't want, the sheeting to be vertical, which it normally is, every building. Some architects, want the sheeting turned sideways, or horizontal, and the girts don't run that direction. So you would use hat channels over our girts, to do that. Like I said, that's one of the most common ways of using it.
Well, I think the hat channel, the best application for hat channel, I mean, besides outside sheeting, would be drywall or plywood for interior finishing.
It's true. That as well. Yeah.
I'm not finding a good image of hat channel on Purlin.
Yeah, I mean,
I'm finding a good,
going back to those cold form versus hot roll, sometimes they use that hat channel on top to work as a purlin.
Yeah, I mean, I think the easiest way for me to explain it, it would work to change your panels to run horizontally, but hat channels are good, like on the interior of the building system, to run vertically from the floor up to the eave strut on 16-inch centers in order to install drywall, right? So we can run our girts or purlins, whatever, on as tight as centers as we want. We've done them as close as 16 inches before. It makes overall construction, I think, easier when you're talking about 2 foot on center, but the cost does go up, right? So if you can span, if the building system's fine with 5 foot purlin spacing or 5 foot girt spacing, it's probably going to be a lot less money to have these little hat channels, these 3/4 inch hat channels on 16-inch centers running vertically to act as a traditional stud.
Yeah. Well, and the only reason if you're using drywall, you got to, make sure that we can get into this never mind. It's a lot.
You're talking about deflection limits?
Well, no laps, when you do, for taping and, if you're doing drywall, there's just a lot of different specs that you need to follow.
Yeah.
That's why you use hat channel.
Yeah. So if you're putting, I think what you're trying to say is it's like decking a roof, right? If your purlin spacing is 3.5 foot on center and you're going to deck the roof, you're wasting an awful lot of plywood up there because it needs to terminate on those. So 16-inch centers is going to be any standard building product, decked roof. drywall, whatever. 2 foot also
Exactly.
works, right? As does 16, obviously. But I was looking at this one. So if you imagine this being a girt in the building and then hat channel running here, now you can suspend something off of this or hang or, attach something else to it. That is how a hat channel works.
All right.
I'm going to talk until you guys talk.
Yeah. Well, we could sit here a while.
I do have something I was going to show you guys. This is, I want to be careful because I want to be very friendly. I don't want to offend anybody. Let me see.
Already.
Yeah.
No,
I'm offended that you
is-
think that I would be offended.
I'm calling HR right now.
okay, hold on. Let me see if I can pull this up.
Mm-hmm.
Ryan sent this over. So we got a call from a customer. His building was delivered months ago and the Erector was out there. This is the wrong one.
Kirby wants to know if a hat channel is typically thinner than 16 gauge.
Generally,
Typically,
it's
you can get, yeah.
22, 24.
Yeah.
Sometimes
But
18,
typically 16.
but yeah. It can be. I think that the Kirby, the other thing is too, is generally the hat channel is not necessarily taking any load, which is why it's thinner. It's just transferring the load into our girts or purlins, which goes back into the main frames. So that's why it can be thinner.
Hold on, guys. I'm sorry. I'm trying to find this. This is good. I mean, it's not good. It's bad, but it's kind of funny. And it was Ryan that sent it to me, or maybe it was Tony.
We didn't talk about base spacing.
All right, talk about base spacing.
Well, base spacing. Man, I opened up a can of worms.
Go for it, Justin.
Yeah. So the distance between any rigid frames is base spacing. I forget the typical sizes that we have. Actually, don't we? We fluctuate quite a bit. I believe it was 20 is typical, 20, 24, something like that.
20 is
Correct me if I'm
generally where we would like to be at. Yeah.
But they're adjustable.
Yes. Yeah.
Yeah. And it's pretty common for customers to move theirs around quite a bit. You can do it on a 3D building generator on our website, and things get moved around often. But the idea is to spread the load over each bay. So yeah, I think that's a pretty common one that comes up often as people would understand that term. I wish I'd have.
Okay, I got it.
All right. What is it?
Picture real quick.
Okay, so the video is a little bit long, and then we'll end the deal. But here, let me pull this up, and I'll explain it when I start this video. Screen window.
Oh my gosh.
Have you seen this?
Yeah.
Okay.
No, I haven't seen this. What's going on?
So what we have here, fellas, is customer calls into customer service, says, "Hey, we're missing all of our warehouse items." Customer call says, "Hey, we're missing all of this stuff." We're like, "Wait, how did you miss your warehouse box in the trailer?" No, it was never delivered. We talked to the Erector or the contractor that was actually handling it. It was never delivered. So we're like, that even as for Great Western, that is a hard one, right? To be like, yeah, we probably missed that. So they say, yeah, we're going to have it. This is in Florida. And we're like, this was delivered almost a year ago, way outside of the warranty window. But if it wasn't there, we're of course going to take care of it. Anyways, long story short, we send pictures of the stuff on the truck. Customer's like, wait, no, we talked to the Erector. This is the Erector, one of the Erector's crew, after cleaning up the job site, after they moved the building out of their parking lot, dumping our warehouse box into the trash can.
Oh, gosh.
And God bless this company, right? Because our customer service team was talking to him. We sent him pictures, and their accountant is like, "I'm going to get to the bottom of this. We have footage of everything." And some people are angels. He sends over an email. And he's like, "I figured it out. Here is the link to the video." He was so embarrassed, and he sent it over. So I thought this was this was pretty funny. So we did for anybody that's wondering, we did replace the warehouse box for them, and they covered the freight on it. And we felt like that was a good compromise since they were so honest and happy to take responsibility for it. But pretty a little comical, I thought.
Yes.
Yeah. I watched this the other day. It was
tragic and comical.
Yeah, that box must have been a little heavy too.
Yeah, I don't know what the guy was seeing. I think what probably happened is the GC, the superintendent, some boss said, "Hey, go get my parking lot cleaned up. If we don't need it, there's a dumpster, throw it away." Because I've done that here before, where I'm walking, Aaron, I'm walking around the yard and I'm like, why is that stuff there? Are we ever going to use it? Like all those old heaters that we have, those aren't going to be used. Call the recycler, tell them to come, get it out of there. And apparently, though, that was one of the Erector's crew.
Wow.
Oh, wow.
Yeah, that's crazy.
All right, we're way over our hour. I have a meeting. They've been trying to get in here. Justin, I will see you tomorrow.
Yeah. I'll see
And
Garrett.
you guys-
Noonish, I assume. 1 o'clock.
No,
like that.
no. He's not going to get out of here till at least 1. So you won't see him.
Okay, that gets, so I can get a lot more work done today. That's what I'm hearing.
Yeah. All right. Everybody
All right.
party on. Have a great weekend.
See you guys.
See you. Happy
Labor Day weekend.
Labor Day.
Labor Day week.
Labor Day.
Nice.